Today we're talking about solving by substitution or elimination. Do you guys remember this from Algebra 1?
Yes.
How many of you are good at this? Okay. How many of you are okay? How many of you totally forgot how to even do this? Okay. All right, so a little bit of everybody. Okay, so there's multiple ways when you're solving systems of equations, there's multiple ways to find the answers. So we're going to talk about the substitution method and then also the elimination method. The goal is to basically get an answer for an x and an answer for a y, which will end up giving you an ordered pair. Okay? So the first thing, if you want to solve by substitution, is you'll solve one of the equations for one of the variables, so x or y. Well, you don't want fractions because fractions make things a little bit more complicated. So if you look at these two different equations, see how this equation has x where it doesn't have a number in front? This would be the easiest one to solve for a variable, okay? So we would subtract 4y to both sides and get x equals negative 4y plus 1. So now I have x by itself. And then at this point now, you can substitute the equation here from one into the other. What I mean by that is, see how this says x equals negative 4y plus 1? You take this and plug it into the other equation for x. So instead of writing x here, I'm going to end up writing negative 4y plus 1. Can you guys see okay in the back, or should I make this bigger? You guys want it bigger? Yeah? Okay. I know. It's okay.
You have to multiply the 2 to negative 4y.
Yes, you do. So we are going to plug it in, and we have 2 times negative 4y plus 1 minus 3y equals negative 9. Okay, and we're going to do exactly what McKenna, right? Just what? Okay. Okay, and we are going to distribute the 2. So we distribute the 2 through here, and we get negative 8y plus 2 minus 3y equals negative 9. Good. We're going to simplify, combine our like terms. So negative 8y and negative 3y will make negative 11y plus 2 equals negative 9. I didn't give myself enough space here. And then we subtract 2 to both sides. Negative 11y equals negative 11. Divide by negative 11 to both sides to get rid of that. And we find that y equals what? 1. Okay, so we have y equals 1, but you actually need to know what x and y equals. Well, once you have this, if you take this and plug it back in here, x is already all by itself, so all you're going to have to do is simplify. So I'm going to take y equals 1 now, and now I'm going to plug it in here for y. So I get x equals negative 4 times 1 plus 1. And negative 4 times 1 is negative 4 plus 1, and what will that make? Negative 3. So that means the answer, and we always want to write our answer as a coordinate pair, we write that as negative 3 comma 1. Because it always goes x value, then y value. Yes? No. So like if you wanted to take this and plug it into one of these two equations, you would get the same answer. You would just have to you would have to take a little bit more time. It'd take more work because you have to move things around, but it will work in any of them. Good question. Any other questions about this one? Okay. So example 2, this one was kind of figured out for you if we look at this. But you have 2 equations here, and both of them are y equals. Okay? And I don't know why, but this like confuses people sometimes. But basically what they've done over here is they took, since it says y equals 3x minus 8, they took this 3x minus 8 and plugged it into this equation for y. So again, we're just using substitution. It just looks a little different. We didn't have to change one of the equations. So now we have 3x minus 8 is in for y, and then you still have 4 minus x on the other side. And then you're going to move things around so that you can solve for x. So here they added the x's to both sides so that this side doesn't have x's anymore. 3x plus x is 4x. Minus 8 equals 4. Then we add 8 to get all your numbers by on the right. And so now you have 4x equals 12, which means x equals 3. Okay? So now that you have x equals 3, you can plug it into any of the equations. Okay? In this case, they chose the bottom equation because it looked more simple. So we plug in x equals 3 into there. So that's how they got y equals 4 minus 3, which means y equals 1. And then how should you always write your answer? Ordered pair. Good. So that will be perfect. Now, do you think it matters? Okay, we're going to talk about the addition method here in a minute. But if you end up liking the elimination method or addition method better than substitution, will you always get the same answer no matter what method you use? Yes. So even if they say to solve by using elimination or solve by using substitution, if you want to use a different method, it's fine. You're going to still get the same answer. But let's go ahead and just stick to substitution for this one. So remember, you always want to get one of your equations so that it is the variable equals something, right? So x equals an equation or y equals an equation.
Can I give you the first one because of the negative y?
Yeah, so the first one would be the best one because it has a y that's by itself. You don't want a number in front of the y because you could end up with fractions, which would make it more complicated. So if we are going to take this equation and solve for y, let's just do this right here. We have, so I'm just going to rewrite this. 2x minus y equals 6. So in order to get y by itself, what would I need to do? Good. Subtract 2x to both sides. So now, don't forget about your negative in front. I have negative y equals negative 2x plus 6. And what would be my next step?
Divide by negative 1.
Very good. Divide everything by negative 1. And when I do that, I get y equals 2x minus 6. Now, you can't plug this into the equation you just used. You have to plug this into the other equation. So that means I'm taking 2x minus 6 and I'm plugging it in for what?
Y.
For y. Good. Okay. So I'm going to rewrite this equation now, and it'll be 8x minus 4 times 2x minus 6 equals 13. And we need to distribute. And you are making sure that you distribute the sign as well. We're distributing negative 4 through the parentheses. So I have 8x, negative 4 times 2x is? Good, negative 8x. Negative 4 times negative 6 is? Positive 24 equals 13. Well, when you simplify this, 8x minus 8x equals 0. So these cancel out. And so we end up with 24 equals 13. Well, is that a true statement? No. So that means that this answer is no solution. If something like this happens and your variables cancel out and you ended up with like 5 equals 5, let's just say, what answer do you think would be to this one? It would be all reals. It means that they would be the same line and the answer would be all solutions because they would be, the lines would be right on top of each other. Does that make sense? Where this one, when there's no solution, that means they are two parallel lines. So they're never crossing. Okay, so there's no point of intersection. Because really what you're doing here is these are two lines and you're finding the point that the two lines intersect. Okay? Do you guys have questions? No? All right. Let's move on. So elimination. Elimination tends to be the method that most people use. And when you're using the elimination method, you are trying to make it so that when you add the two equations together, it eliminates a variable. Okay? Yes, McKenna. Oh, okay. So, first thing you have to do is make sure both equations are in standard form. Remember, standard form is when you have your x's and y's on one side and your plain numbers on the right. So in this case, both of these are in standard form. Then you need to make sure the coefficient of one of the variables in both equations should only differ in the sign of the variable. So what they mean is you need like one to be a positive 4x, but the other equation to be a negative 4x, so that when you add them together, it cancels them out, right? So if we want to go ahead and do that and get rid of the x's, we would need to multiply this top equation by what number?
-2.
Very good. So let's go ahead and do that. So don't forget that you're multiplying every single term in the equation by -2. When I multiply through there, I get negative 4x, negative 10y equals negative 28. And then I'm going to go ahead and add these bottom two equations together. So this is just to kind of show you what I'm doing. So the x's cancel out. 2y and negative 10y make what?
-8y.
Negative 8y equals, and negative 4 and negative 28 makes?
-32.
Very good, because we add, keep the sign of the negative. And then to finish solving for y, what do I do?
5 and -8 is
Not negative 4,
-4.
positive 4, because two negatives divide and make a positive. So y equals 4. Very good. So then you have y equals 4. Does it matter which equation I plug this into? No, you can plug it into the top equation or the bottom. Either way is fine. What? Or the third one. You're right. You actually have 3 equations. You could put it into any of those. Thank you, Marcus. All right, so I'm going to take this. I'm going to go ahead and just plug it into the first one. You could do it to a different one if you want to. So I get 2x plus 5 times 4 equals 14. 5 times 4 is what? 20. So 2x plus 20 equals 14. Then I will subtract 20 from both sides. 2x equals negative 6. We divide by 2, and x equals negative 3. So my answer is negative 3, 4. Questions? Okay. Example 2. What don't we like about example 2? Fractions. Can we get rid of fractions though?
Yeah.
Yes. So you always look at each equation separately. So on the first equation, in order to get rid of the fractions, what would I need to multiply by? No. Because if I multiply every single term by 3, is 3 going to get rid of a 2? No. 6. So the common denominator would be 6. So I'm going to multiply every single term in this equation by 6. When I do that here, 3 goes into 6 how many times? 2. And so you have 2 times 1 times x, which makes 2x. Okay, here 2 goes into 6 3 times, and 3 times 1 times y is 3y equals, and 6 times 7 is 42. Okay, now again, these are separate equations. So on the bottom equation, what would you multiply every single term by? 3. Okay, and again, where people usually mess up is multiplying every single term. So make sure you write 3 next to everything so you don't forget. So with the x's, the 3's cancel out, and we're left with 2 times x, which is 2x. Then 3 times negative y is negative 3y equals 3 times negative 2 is negative 6. Now, is this already set up for elimination?
Yes.
Yes. I don't, look at the three y's. One's positive, one's negative. We don't even have to multiply by anything. They automatically are canceling out here. And then 2x plus 2x is
4x.
equals, and 42 minus 6 is
36.
36. Very good. We divide by 4 to both sides, and we find that x equals 9. Now, x equals 9. You have 4 equations you could plug it into this time. You could go back to your originals, or you can go to the ones without fractions. I'd prefer the ones without fractions, but totally up to you. So I'm going to take x equals 9. I'm going to plug it into this first equation right here. So I have 2 times 9 plus 3y equals 42. 2 times 9 is 18. Plus 3y equals 42. Next we subtract 18. 3y equals 24, right? And then, good, divide by 3 and y equals 8. And how do we always write our answers?
9, 8.
Good, ordered pair, x and then y. So 9, 8 is the correct answer. Okay, just real quick, how are you guys feeling about this lesson? Thumbs up for good, down, this is horrible. All right, most of you are okay. To the side means, I'm okay. All right, example 3, who remembers how to get rid of decimals? Good, so if we look at the first equation, how many numbers are behind the decimal place? 1 for all of them, right? So if there's only 1 number behind each of those decimal places, what am I going to be multiplying by? 10. So I'm multiplying this equation by 10, and when I do that, you move each of the decimal places 1 time. So my new equation is going to end up being what? Good. 22x plus 35y equals 9. On my next equation, again, the largest amount of numbers I have behind each decimal is what? 10 as well, or 1 place. So I'm going to multiply each of these by 10. So what do I end up with on this equation? Good. So we get 33x minus 14y equals 80. Okay, which one what do you think is going to be the easiest one to get rid of? The x's or the y's? You can divide, or they have 11 as a common number factor. Okay, so if we want to get rid of the x's, what would I need to multiply the top equation by? No, not 11. 3. Okay, because this number is 2 times 11, and this number is 3 times 11, right? No, it's okay. So we want to multiply the top one by 3, and then I need to multiply the bottom equation by what? 2. Okay, but one of them also needs to be a negative.
The top number.
It doesn't matter. I made the bottom one negative, but it doesn't matter. So when you multiply through here, 3 times 22x is 3 times 35 is 105 equals, and 3 times 9 is
27.
okay. So now we're going to go to the bottom equation. Negative 2 times 33 is
Negative 66.
good. Negative 2 times negative 14 positive 28y equals, and then negative 2 times 80 is
Negative 160.
good. Okay, so these cancel. 105 plus 28
140. 144. 143.
133y, I believe.
No, you're wrong because you have to add it. You have to carry a 1. Because you did 5 plus 8, and that's 13. And 1 plus 2 is 3. So then we got 1 got 8. Because
8 plus 5 is 13. 3 carry the 1. 1 plus 0 plus 2 is 3. And then that one is in hundreds place. It's okay.
it looked like the 2s.
Yes, I can see where that comes from. Okay, so and then you have negative 160 and 27. What does that end up making? Good. Negative 133 is correct. And then in order to get y by itself, what do I do? Divide by 133 to both sides.
And you get
Y equals negative 1. So now we take this. I'm going to go ahead and plug it into the first equation. You can plug it into any one you want to. So if I do that, I have 22x plus 35 times negative 1 equals 9. Oops. 35 times negative 1 is negative 35. So I have 22x minus 35 equals 9. We add 35 to both sides. 22x equals 44. We divide by 22 to both sides, and x equals 2. So my answer for this ordered pair is 2 comma negative 1 is correct.